For this problem, we're going to be finding the distance between a point and the line. Since our audience is going to be 9th graders, so we're going to be using geometric properties to prove the problem and solve the problem. And we do assume that they would have already known the basic equation of finding the area of triangles and squares.
Thank you. So, to prove this, we're going to start with a random point, x0, y0, and a standard line. This is how the standard equation of a line is written. ax plus by plus c equals 0. And I drew a line here. Also within this line, for our purposes, we're going to have another point, x0, y1, which is formed by drawing a line that is parallel to the y-axis, straight down. So we know that the first point, the x part, is x0, but we don't know what the second y is, so we're calling it y1. Also, we're drawing another line across and calling this point x1, y0, knowing y0 but not knowing what x1 is. And so we have these two lines. These two lines can be written in the standard equation using our points. So using our first point, x1, y0, we're going to plug it into our standard equation, ax1 plus by0 plus c equals 0. Well, we're going to solve for x1, and it becomes minus b y0 minus c divided by a. Doing the same thing with our second point, x0, y1, we're plugging it into the standard equation, so it becomes this, and solving for y1, which becomes minus a x0 minus c divided by b. So that's our x1 and y1. I redrew our graph to make it to show a distinct triangle with three sides. We're calling A, B, and C of height D. This line we just drew from this point to this line, we don't know what intersecting point this is, but we know that there is a line that is perpendicular to this line connecting to this point. So we can draw this and name it D. To find A, we need to solve this equation, x0 minus x1. So to find this equation, so we can subtract this from this, and the absolute value equals A. Same thing for B, subtracting y1 from y0, getting the absolute value is B. Now to find C, we're going to use a Pythagorean theorem, which is c squared equals a squared plus b squared. The proof of this one is shown on the back.
Okay. So here's a square, and I'm going to be filling up this square by using 4 triangles. So that's how I'm going to arrange my squares. Yeah, my triangle. Oh, no. Here, this is 1, and this is 2, and this is 3. Last one, 4. As we can see, the empty space in the middle, the area of the empty space in the middle, it's going to be c squared. It's based on the equation of the area of a square. And now I'm going to be rearrange my triangles. It's going to be 1, 2, 3, and 4. It's the same. I'm using 4 triangles, and now I have b squared, a squared, and then I'm just going to be adding them together, a squared plus b squared, and I guess c squared, because empty space in the middle are equivalent, which give us the equation of a squared plus b squared equals c squared.
Thank you. So that's how we find C. Now, as we look at this triangle, if we rotate it like this, we can see that A is the height and B is the base of this triangle. So, because you are ninth graders, you should know that the equation of the area of a triangle is 1/2 times A, the height, times B, the base. If we rotate the triangle again, we could see, so that the C is the base, we can see that D is the height. And then the area of this triangle is 1/2 times C, the base, times D, the height. Because this is the same triangle, the areas are the same. We have those two equations equal to each other, and we get AB equals CD after we cancel out this 1/2, and we solve for D, which equals AB divided by C, the distance from our point to this line. Now, the problem that we were given was that we have a point 2, 3, and our line 3x plus 4y equals 5. First thing we're going to do is convert this line into our standard equation so that it becomes 3x plus 4y minus 5 equals 0. And see, from this we can see that 3 is A, 4 is B, and -5 is C. Now we plug it into the equations that we found out from earlier. x1, this is the equation that we solved earlier, and by plugging in all these A, B, and C into this equation, and our y0 from our point 3, we can see that x1 equals -7/3. In the same way, plugging A, B, and C and our point x0 as 2, we can solve y1, which becomes -1/4. So that's our y1, x1, and y1. Using our x1, y1, and our points x0, y0, which is 2, 3, we can solve for A. So our x0 is 2, and x1 is -7/3. We subtract them and get their absolute value, and it becomes 13/3. So our A is 13/3. In the same way, B, through our y0 and y1, we find to be 13/4. Now, using our Pythagorean theorem, which we proved and found to be c squared equals a squared plus b squared, we can see and solve it to find that c equals 65/12. Now our final equation, figuring out D from the areas of the triangles, D equals A times B divided by C. We plug in what we figured out, and we get that D equals 2.6, which is the distance from point to 3 and the line 3x plus 4y equals 5. Thank you.